So actually, when you look at f of f inverse of x, when you plug an inverse function into a function, it should always simplify to x. And the opposite is also true, that when you plug in a function into its inverse, it should equal x. So a function in its inverses, when you simplify, will equal x. What that means is it's symmetric across the line y equals x. Okay, a function in its inverse are symmetric across the line y equals x, like I just said. So remember, y equals x is that linear parent function. It crosses at 0, 0, and it has a slope of 1. So you should be able to fold your paper across that line y equals x, and a function in its inverse we're going to match up across that line. A function is 1 for 1 if it passes the vertical and horizontal line test. So that means every 1x has 1y, every 1y has 1x. So it's 1 to 1 if it passes the vertical and horizontal line test. Okay, so example 1 wants to know if f of x and g of x are inverses of each other. So what we're going to do is we're going to substitute them into each other and make sure that when we simplify, we get x. No numbers, just x. So I'm going to start with f of g. So remember, from composition of functions, we start closest to the x. We're going to take the g function and plug it into the f function. So 7 times, I'm going to put x minus 1 over 7 plus 1. So you can see in the f function, in place of x, I have substituted the whole g function. Now we're going to simplify. So notice the 7 on the outside and the 7 on the inside. Those are going to cancel. 7 times something and then divided by 7 cancels out. So I'm left with x minus 1 plus 1. The minus 1 plus 1 will cancel, and we're just left with x. So far, this would mean that they're inverses, but I have to check the other way as well. So I have to find g of f of x. So I'm going to take the f function and plug it into the g function. So 7x plus 1 minus 1 all over 7. So if I simplify the top first, the plus 1 minus 1 will cancel. Now I've got 7x over 7. The 7's will cancel here. So it just equals x. So since both of these simplified to x, then yes, f of x and g of x are inverses. Okay, number 2, finding the inverse of the function. So like I said at the very beginning, it's when the x's and y's switch places. So that's actually what we're going to do. In place of f of x, we're going to write y equals 3x cubed minus 2. We're going to switch the x and y values. So now I'm going to say x equals 3y cubed minus 2. And I'm going to solve for my new y value. So I'm going to add 2 to both sides. So x plus 2 equals 3y cubed. I'm going to divide by 3. So x plus 2 all over 3 is equal to y cubed. Then I need to undo the y cubed. Well, that's taking the cubed root of both sides. So the cubed root of x plus 2 over 3 is equal to y. So this is the inverse of 3x cubed minus 2. So I'm going to write it as f inverse of x is the cubed root of x plus 2 all over 3. Okay, number 3, we're going to graph the function and its inverse. So we're going to start by finding the inverse of the function. So in place of f of x, I'm going to put y equals. And we're going to switch our x's and y's, and I'm going to solve for the new y. So I'm going to subtract 2 on both sides. So now I've got x minus 2 equals y minus 1 cubed. To get rid of a cube, we're going to take the cubed root. So the cubed root of x minus 2 equals y minus 1. Then I can add 1. Now this one doesn't go underneath the radical. It's going to be outside. So f inverse of x is equal to the cubed root of x minus 2 plus 1. So now we're going to graph our two functions. So you can put these into the calculator simultaneously. Put the original function in y1 and the inverse into y2. So then when I go to the table, I've got 3 columns, my x, y1, and y2. And in my table, I've written x, f of x, and f inverse. So I've picked a few values. I'm going to plot those points. I'm going to plot my f of x function in green, and then my inverse function in blue. So start with -1, -6, 0, 1, 1, 2, 2, 3, 3, 2. So here's my original function, f of x. Now I'm going to graph my inverse function. So I'm going to use the x column and my f inverse column. So -1, -0.4, 0, -0.3, 1, 0, 2, 1, 3, 2. And if I picked a few more points, I would have a better picture of what's going on here. You can look at your graph and see. But here's the graph of f inverse. Remember at the beginning I said that a function and its inverse are symmetric across the line y equals x. So if I graph y equals x, which is this purple line, and I was to pull the graph